Dr. Emily Harper worked in a modest virology lab on the outskirts of Atlanta, in a building that had once been a warehouse for cotton shipments. The air conditioning rarely worked properly. The fluorescent lights buzzed like distant insects, and the fume hoods sometimes coughed more than they vented. Yet for 12 years, this had been her world. She arrived before dawn most days, unlocked the door with a key that had worn smooth from use, and began. Emily was not the kind of scientist who chased headlines. She published modestly, spoke softly at conferences, and preferred the company of her notebooks to that of crowds. What set her apart was something rarer, an unshakable patience married to relentless precision. Colleagues called her the one who never rushes the gel. When others grew frustrated with ambiguous results or contaminated cultures, Emily would simply exhale, sterilize everything again, and start over. She believed that good science, like good barbecue, demanded chimney the right heat and no shortcuts. Her current project had begun 5 years earlier, almost by accident. A surge in unexplained fevers had swept through rural clinics in southern Georgia, patients arriving with high temperatures, joint pain, and rashes that looked like dengue but tested negative for it. The State Health Lab had sent samples to Emily's team for deeper sequencing. Most labs would have run standard panels and filed the report. Emily did not. She noticed subtle patterns in the cytopathic effects on cell lines, consistent changes that standard viruses did not produce. She ordered new primers, redesigned protocols, and spent months troubleshooting contamination that turned out to be her own pipette tips from a faulty autoclave batch. One rainy October evening, alone in the lab after everyone else had gone home, Emily stared at the sequencer output on her cracked laptop screen. The alignment showed a novel arbovirus related to chikungunya, but with mutations in the envelope gene that suggested better adaptation to local Aedes mosquitoes. She cross-checked the sequence against databases 3 times, ran phylogenetic trees, confirmed with Sanger sequencing backups. By 2 a.m. her hands trembled from too much coffee and not enough sleep. But the data held this wazi out. The next morning, she presented the findings to the lab director in a quiet voice, slides simple and clear. No drama, no exaggeration, just the evidence. Within weeks, the virus was named Georgia fever virus, GFEV, and international collaborators arrived to help map its spread. Emily's protocol for rapid detection became the standard in regional labs. Clinics could now test for it directly instead of guessing. Vaccines were discussed. Surveillance programs expanded. She did not celebrate with fanfare. That Friday, she stayed late again, calibrating the old spectrophotometer that everyone else avoided because it drifted. When a junior technician, fresh from university and full of questions, asked why she bothered with such small things, Emily paused. "Because the small things are where the answers hide," she said. "And because someone, somewhere, is waiting for us to get it right the first time." Years passed. The lab got a new PCR machine, funded partly by grants that cited Emily's work. Younger scientists joined, some inspired by her quiet example. One evening, as the autumn wind rattled the windows, a postdoc brought her a preprint from a team in Miami that had used her detection method to identify an outbreak early and contain it before it spread to urban areas. Emily read the paper slowly, then closed the laptop. She walked to the window and looked out at the city lights flickering through the rain. For a moment, she allowed herself to feel the weight of it, not pride exactly, but a deep, steady satisfaction. Lives had been spared because she had refused to accept close enough. She turned off the lights one by one, locked the door, and stepped into the warm night. Tomorrow, she would be back before dawn, no chibuki, opie pipette in hand, ready for whatever small mystery the day brought next. Because excellent science is not always loud. Sometimes it is simply the refusal to stop until the truth is clear.